So again, I do live stream onto YouTube. So I think I worked out the kinks on how to do it. I know somebody's in the waiting room. I'm about to get it early, but I feel like I've worked out the kinks so far. So again, let me stop this. Okay, and let me let these students in. And as I let them in, I'm also going to go ahead and start a poll. So launch, and let me see if I can get these two students. See, this is the kind of stuff I did not want to stream, but it's okay. And, okay. So let's see. Let me think about it. So yeah, so the first announcement is that I do live stream my sessions. I do the best I can to be cognizant of you guys' sensitive information. Hopefully everyone had a good. I wanted to kind of go through the homework. Hopefully everyone had a good holiday with the King holiday. So I went on. So my intent is to post the lectures, like the things that I want to say for lecture. I usually try to make those in advance, outside of class. Together we have like an hour and 15 minutes. I wanted to check the poll. Okay, so there's a poll on Zoom, but most students have been going through. Most classes have been like requesting to go through the homework. And that's probably what I'll do here because we don't really have enough time to go through the lecture like I would. But if you all as a collective would like to go through the lecture, we can do the lecture instead of the homework. But again, this week, the intent is to go through 1.3 and 1.4. Last week was 1.1 and 1.2, and we did the best we could with whatever time that we had. Today is what? Wednesday? And so we lost out on Monday this week, right? Okay, so right now, majority is requesting to go through the lecture. So we'll go ahead and we'll kind of touch on section 1.3. I don't know that I'll be able to make it through all of 1.3, but we can start the lecture. Now, again, the lecture that I'm about to do is already recorded on my YouTube channel, right? But I totally get going through the lecture over the homework, but that's why I do a poll. But majority are requesting to go through the lecture, so we'll take some time to go through the lecture. I'll leave the poll open. Let me see. I think I have a blank copy. Where is the blank copy? Section 1.3. There's the blank. So let me edit, and I just want to duplicate this. Duplicate, and this one. We'll go ahead and work here. Okay. So let me make sure. I think the stream is working. And again, it is important that you are subscribed to my YouTube channel with your notifications turned on. It is a shameless plug, so ain't no shame in my game. But again, that's going to be like our main way of communicating this semester. Like that's what I'm going to be doing all of my recordings and things of that nature. Let me check Zoom one more time. I don't think anybody's in the waiting room. Go ahead.
Let's see.
Yes, Professor. So I added this class to my schedule last Thursday, so I missed the first class. So I'm confused on what homework you are talking about.
Let's see. Okay, so are you able to access our Blackboard page?
Yes, sir. So
you want to start on Blackboard. On Blackboard, there are 4 key links. The first link, let me see if I can pull it up. Because I don't think it'll hurt to kind of just recap. So if we go to the portal, let's see. Okay. So for instance, if I go to Blackboard, and if I go to our course, so the landing page looks something like this. Hopefully you can see my screen. You should be able to see my screen.
Yes.
When I click on that link, so you made it into the Zoom. So that's obstacle number 1. That's the main thing. Now you know how to contact me. Emails are fine, but I generally just don't check my emails. I just be I just don't check. But it's good. It's good for record keeping, and at least it's on file. The best way to communicate with me is during class time. And so we're doing a remote asynchronous course, which means each class, I just need you to get the attendance credit at a minimum by getting into my Zoom. You're not obligated to stay. And the intent of our class, or the setup, is for class to be really a Q&A, so a question and answer study session. So with that being said, I make the lectures in advance. So here, let's go through these links really quick. So you made it into the first link, which is my Zoom link. So you got that checked off. So the second one where it says daily lecture notes or box link, you'll find like a PDF copy of anything that you see me writing on the screen, right? You can find it there. Any handouts and any PDFs, you can find it there. And then our assignments is that section number 3 where it says all assignments. We're using Pearson. And so you access it, like when you click on all assignments, and if I click on the first one that says all assignments, you're going to be prompted to register for Pearson, right? So that's how you access our homework. It's all there. Homework, quizzes, and exams are all going to be in that link. I've already posted all homework and all quizzes for the semester. You can actually access them now. You just have to be aware of the due dates. So be cognizant of that. Let me get these 2 students.
Okay.
Hang on. Because I'm not done. I'm just trying to get these students. Go ahead.
Yes, so I've ordered the book and it's on the way. So I don't have it yet. So I can't really register for Pearson. So I was just trying to get a gauge.
Yeah. So even with Pearson, if you're waiting on the access code, okay, there's a couple of things. If you use Pearson in the past, not Pearson, but if you use this exact same book and you have an access code from that book, you can use that access code to access Pearson. You don't have to purchase another one. So like if you're using the exact same book and you have an access code from last time, you can use that access code. And if you're waiting on an access code, you can go ahead and still follow those lines or whatever to get into our homework. And there should be an option to get 14 days of temporary access. So you can go ahead and get 2 weeks of temporary access and go ahead and get started anyway. Do not hesitate because this stuff will pile up fast. Okay. And then, and then the last important link on our Blackboard page is this link number 4 that takes you directly to my YouTube, more specifically to this playlist where I'm collecting all the recordings for this semester. So I only have 2 classes between Calculus for Business and College Algebra 2. And I'm dumping all of my recordings into that one playlist. And this link takes you directly to that playlist. So all the important stuff is right here on Blackboard. Any question that you need is right here on the screen that you see. The syllabus is over to the left and everything is there.
Okay, thanks for the clarification.
So with that,
Professor.
Go ahead.
Oh, yeah, I just had a question just quickly about the class structure overall. So like, for example, once you take attendance and check in, like we can ask questions, but if at the point like we've done the assignments, we're up to date and we're good. If we feel comfortable, we can leave the class. We don't have to stay for the whole duration of the class.
Even if you're not comfortable, you don't have to stay. Like it's really, I really just did it as I do asynchronous. So only thing I need from you is like basically just get your attendance credit and just check in with me every day so I know that you're alive, that you're okay, and I can at least touch bases on some level energetically so I can say, okay, I heard from this student, I know they're okay. Or I was like, okay, wait a minute, do you need some help or how can we assist? What do we need to do, right? So the purpose of class is really just a check-in and like an opportunity for you all to ask questions. But the real lecture is like on your own with the pre-recorded lectures and the homework. And so like with the homework, I encourage you all to, use Pearson as best you can. Definitely link up with your classmates. I'm pretty sure there was a group meet going around. So if you're not part of that group, you definitely want to just go ahead and get into it. I just encourage it. It's totally okay. And then you definitely want to also go ahead and seek out the tutors. Go ahead and like find them, know how to connect with them, know their schedule, and go ahead. And it's okay if you want to take this information and sit down with them and go through it with them. You've already paid the tutors. So if you don't use them, you're just throwing money out the window. And then lastly, you definitely want to come to me. Once you've done those 3 things and I give the presentation, usually it clicks. Okay. You can come to me first, but sometimes I notice the students kind of feel overwhelmed and they kind of get shut down. But when you follow the other suggestion, do what you can on your own, do what you can with your classmates, do what you can with the tutor, Then when I give the exact same presentation, it's usually a lot better. Okay. These are good questions, and like just keep them coming. It's totally okay. That's the nature of the design. And I chose class time as the opportunity to do that because I know that's the time when everybody's available. Usually, when I choose other times, it clashes with somebody's schedule, and people can't really link up the way they need to. But at least this way, we have a setup. We have a plan to do what we need to do. Okay. So that was fun. That was an adventure. Go ahead. Yeah. No worries.
I missed the first class as well. But I was curious about, so you mentioned tutors. So is that just something we access through Starfish, or is there like somewhere else we got
Now,
access?
in the past, I mean, there was a link on Starfish in the upper left hand corner on that little hamburger three thing. I would start there. If that doesn't work, contact the math department, and they'll tell you how to contact the tutors. They may or may not already be set up, but you want to be seeking them out, right? You don't want to hesitate with that.
Okay. And then so we missed the first week. If we missed the first day of class, and everything like that, how do we get caught up? And then how do we as far as like proceed with like doing the homework and stuff like that we missed?
Okay, so if you missed the first class, there is a copy of the orientation on my YouTube. So you just go to the Blackboard, go to that YouTube link, click on it. It'll take you directly into the playlist. Go ahead and subscribe to my YouTube and turn your notifications on. And then you'll see like Calculus for Business Orientation. It's basically a playlist of all the recordings, right? So even this one, I'm going to put into that playlist, this recording now. And then you can see all the things that we did. And so basically all of the learning is remote and on your own. And then we use class time to kind of clear stuff up. So today I'm doing the best I can to go through sections 1.3 and 1.4. So last Wednesday, we went through orientation 1.1 and 1.2. We did what we could together, but I had all this stuff pre-recorded. So whatever we didn't do together, you're responsible for your own. And then as far as the homework is concerned, so with all the homework on Pearson, we get unlimited attempts at all assignments. That means homework, quizzes, even exams, I'll go ahead and give you unlimited attempts. But the thing is, all assignments have a due date, right? So leading up to the due date, you can earn up to 100%, but past the due date, you can work on any assignment past the due date, but then there's a 10% late penalty. So if the due date has already passed, the highest you can earn is a 90, right? That's with all assignments, homework, quizzes, and exams. And it's pretty much the same structure for all. Now, the only thing you're gonna notice is different. When you go to take my exams, they're gonna change up. Like it'll be the same content, but the questions are gonna change each time you take it. So you wanna have some level of familiarity. I cannot get that word out, that's the best I can do. You wanna be familiar with the content as best you can before you start the exam. But once the exams are out, you definitely wanna try to maximize those as best you can. There was something else. Hang on. Yeah, go ahead.
I was just gonna follow up briefly. So you said just making sure, you said all the assignments and quizzes and exams are open right now though?
So all homework assignments are open, all quizzes are open, but the exams release at specific times. So for instance, we're gonna have 2 exams and a final. So exam 1 is gonna release during week 6. There's gonna be 7 days where you could earn up to 100% on exam 1. After that 7th day, at whatever the due date is that I have set, then you can still work on it with the limited tips, but the highest you're going to earn on any question submitted past the due date is 90%. Right? And then exam 2 is scheduled to release during, I think it's like week 13. They got kind of offset because of the spring break. Right? See the week 13 or 14, something like that. All right. These are good questions. All of these questions are in the orientation, but it's totally fine to ask them now too, because everybody may or may not know these things. So, you know.
And real quick, before you discuss the next chapter, can you extend the deadline for the first week's assignment?
So it's already kind of like an inherent extension, and 10% off of one homework assignment that's not going to affect your grade hardly at all. Like each homework assignment might boost your grade by like maybe 1%. So you're talking about 1/10% of your overall grade that you might miss out on for that homework assignment, because that's all that's been due. It's homework 1 and quiz 1. So you're not missing a lot. The homework is only 10% of your overall grade. Sorry, I think it's less than that. I think it's like 7.5% of your overall grade, and the quizzes might be 7.5% of your overall grade. So getting a late on homework 1 and quiz 1, the main thing is just maximize their score as best you can and go ahead and get started. So all the assignments have a natural extension already built into them. But I also need to mention that there is a hard deadline. That May 1st, which is a Sunday night, going into Monday, going into the week of finals, that's the hard deadline. So everything locks out at that point. So once we start that week of finals, you'll have maybe 5 days to access the final. And that's all that you're going to have access to is the final during the final period, right? So right now, everything has a natural extension already built into it, but the hard deadline is May 1st. Okay. So 10% off of that first assignment is not gonna affect you hardly. Okay.
Professor, I have a quick question. So
go ahead.
Since I failed business calc last semester, will this grade replace that grade from last semester?
It will. I think that original grade will still be in your transcript, but as far as your GPA is concerned, this should, provided you do better.
Okay.
It should replace that. It should replace it on your, as far as your GPA is concerned.
Okay.
And that's my impression or my understanding as far as how that goes. You're probably better off asking like a counselor, the counselor or something like that, the registrar or something like that. They'll know better than that.
Okay.
No, you right. That's how it goes. It's gonna still be in your transcript, bro.
But it'll repair your GPA. Like, that's just what it is. And that's, it'll be okay. Like, don't stress too much about these things. Like, you just do the best you can, because honestly, this stuff is, I don't want to be like it's a joke. Maybe it's just me, but it's kind of a joke. It's not a joke. It's a lot more nuanced than that. It's not that straightforward. But what I mean is, like, when they go to review your transcript, first they'll see your GPA, and then they might notice that grade. But if your GPA is a certain point, and depending on what you're doing, it'll just be a moment of like discomfort. But as long as your GPA is in order, you can repair it. There's always a way. There's always a way around different things. So even if you have like a crap transcript or you don't graduate, there's always a way to get stuff done. I know people that have no education whatsoever, and they're slugging and bugging around. They're way better off. So it's like you never really know which way these things are going to go. You just have to be clear about what it is that you want to do and go after it, and know that there's always a way to get something done. No matter what happens, there's always a way. If, like, for instance, if you're talking to somebody, any kind of official or anybody, and they're not saying the stuff that you want to hear, that just means you're talking to the wrong person. You just got to find the right person to talk to for them to say, do what you need to do. And I actually learned it from one of my students, one of my former students. That's what she taught me. And when I tested it out, I was like, damn, she's right. So there's always a way to get things done. Just do your best, forget the rest, don't stress, and be blessed. Okay, let's get the party started. That was fun. Okay, so we'll do the best we can. Again, so the things that I'm gonna go through today as best I can. There are already recordings on my YouTube channel for what I'm about to do. But I don't mind taking some time and like at least introducing these notions or concepts together. So we're continuing chapter 1 on differentiation. And so with section 1.3, we want to talk about average rates of change, right? So from college algebra, from pre-cal and any class before this, and for our discussion, average rate of change is basically the slope between 2 points, right? And like, so you'll see it presented different ways, but whenever you see average rate of change for our context, it's just the slope between 2 points. So if you know how to find the slope between 2 points, you know how to do average rate of change. Don't get fooled by the presentation and the guides, whatever. So some objectives here: we want to compute an average rate of change, and we want to find the simplified difference quotient. Okay, so we're going to see what these ideas are. Okay, so definition: as x approaches a, the limit of f. Here, let's do this. So as x approaches a, the limit of f of x, this L, is written as this, right? So we're talking about limits. Now let me finish this and give a little synopsis of limits. This is read: the limit as x approaches a of f of x is L. Right? Again, let's do that one more time. The limit as x approaches a of f of x is L. Okay. If all values of f are close to L for values of x that are sufficiently close to a, right? So the limit, when all this discussion about limit, we're just concerned with how the function is behaving as x is close to some number. Okay, so limit is not so much concerned with the value at that number. Limits are just concerned with how does the y value behave as x gets close to this number coming from the left and coming from the right. That's a hopefully that's not overly simplified synopsis of what limits are. Okay? So then another definition, the average rate of change of y with respect to x as x changes from x1 to x2 is basically the slope, right? It's the ratio of the change in the output to the change in input, right? So slope from before should be rise over run or change in y over change in x, right? So again, average rate of change is just slope between 2 points. Right? So we're going to take this notion of slope or average rate of change and extend it a little bit further. We're going to kind of extend it. Okay? And if anything is not clear, just stop me and we can go back and talk about it. So if we look at the graph of a function, so this is just some generic function we haven't rated here, right? We have some generic function. And if we consider the slope between 2 points, right? So we have this first point P, which is x1, y1, and then we have this point Q, which is x2, y2, right? So if we want the slope between P and Q, is just change in y over change in x, right? But we can rewrite that y, so y2 is the same as f of x2, right? That's what you see here. y1 is the same as f of x1. You see it here. So all they did, they just took the slope formula and just replaced the y's with function notation. Okay. So if we look at the graph of the function, we see that the slope is basically f of x2 minus f, basically all of this, right? Which is both the average rate of change and it's the slope of the line from P to Q. So the line through P and Q, represented as line PQ, is called the secant line, right? So a secant line is basically a line that intersects a curve more than once in this fashion, right? So this line is a secant line to this curve because it crosses the curve once and twice, right? It crosses it more than once. Okay. Again, stop me if anything is not clear. Hopefully we're all aboard and not all bored. So for example 1, right? Let's give this a go. So for y equals x squared, right? Find the slope or find the average rate of change as x change. Now we have these different scenarios, right? As x changes from 1 to 3, from 1 to 2, and 2 to 3, right? So because they gave us 2 different x values, that means we could find 2 different corresponding y values, and then we could find the slope between those 2 points, all right? Let me see if I think I got enough space. So for part A, for instance, if I'm working here. So when x is 1, the corresponding y value, if we plug 1 in, 1 squared is 1, right? When x is 3, the corresponding y value, 3 squared is 9. Okay. So average rate of change, we can do, I'm just going to write it like y2 minus y1 over x2 minus x1. So then let's go x1, y1, x2, y2. So then this is going to be 9 minus 1 over 3 minus 1. That's going to be 8 over 2, which is 4. So that's it. I didn't want a box. Let's go with this. Okay, that's better. Copy. Action style. Okay, again, just stop me if anything is not clear. And I'm actually going to rearrange this like so, like that. I don't know if any of you all like listen to like Tabitha Brown on YouTube. She's like a comedian. She just recently opened like, I guess, a restaurant. She's like vegan, and she just always she has this like very distinct character and personality. And so her clip, she always says like so, like that. So if you ever hear me say like so, like that, it's coming from Tabitha Brown. One of my favorite YouTubers. Okay, her and Infinite Waters are smart. It's a few people involved. Anyway, let's do part B. So let's say x1 when x is what, 1, corresponding y value, I think we already said is 1, and then x2 being 2, so the corresponding y value, when you plug in 2, you get 4, right? So I think this is kind of straightforward. We're just going to say 4 minus 1 over 2 minus 1, which is 3. Okay. That was B, and then let's go ahead and do part C. So then for part C, you see the time, okay. So then x1 is what, 2? The corresponding y value is what, 4? x2 is 3. The corresponding y value is 9, right? So then if we find the slope, that's going to be 9 minus 4 over 3 minus 2, which is what, 5. Okay, 4, 3, 5. Okay, let's see, how do we do? We got 4, 3, 5. So you see the result here. Here's a type version with the type version of the solution of what we just did. And you see the 4, and I think we got 3, and we got 5. Okay. So I think they did the same thing, same explanation. So I'm just going to kind of go on to the next one. For the sake of time, I'm going to defer you to my recording for this quick check. I'm going to leave that as an exercise for you. And I went through that in the video because it had extended time. I'm going to leave this one as well, just because I'm going to defer to my video. And let's talk about this definition. So the average rate of change of f with respect to x is also called the difference quotient, right? So difference quotient is nothing but the average rate of change, which is nothing but the slope, right? So difference quotient is just another way of saying slope between 2 points. So now, before, we had x1, y1, x2, y2. But now, instead of doing 2 different x values, what we're doing is we're saying consider some x, and then we're going to let h be some change in the x value, right? Some small change in the x value. So we're considering some value of x, and then we want to add some small change to that x to produce a second x value called x plus h, right? We just added some small change to the original x. So now we have x, and we have x plus h, right? And then, so if we have x, that means we have f of x. If we have x plus h, that means we have f of x plus h, right? So now if you take the slope formula and do these substitutions, once you simplify it down, that's where the difference quotient comes from. You see your y2 is this minus y1. You see it here. And then if you were to say x2 minus x1, the x's cancel, and all you're left with is h, right? So difference quotient is nothing but the slope between 2 points. Is just a change in the notation. Instead of doing y2 y1 and x2 x1, we're doing f of x plus h minus f of x over x plus h minus x, which simplifies down to this. Hopefully, I know that's kind of a mouthful, but hopefully that makes sense. Again, h is just some small change in the x-axis. That's all it is, a small change in the x, right? So the difference quotient is equal to the slope of the secant line from basically these 2 points, x comma f of x and x plus h comma f of x plus h, right? Difference quotient is the slope of the secant line between these 2 points. So we're still just talking about slope, we're just changing the labels, okay? So now let's look at this example. So for f of x equal to this, we're asked to find the difference quotient given these conditions, right? So if we're going to use the difference quotient, it's a good idea to write it down, right? So the difference quotient, I'll put it here, is going to be f of x plus h minus f of x all over h. That's the difference quotient, right? And I'm just going to label that as star for right now as a reference, right? So then for part A, that difference quotient is going to be equal to, so let's find the parts first. Yeah, before I plug it in, let's find the corresponding part. So if we look at f of x plus h, that's going to be f of, now our x for part A is 5, our h is 3, right? So then that's going to be f of 8. So then 8 squared is what, 64. Okay, that's f of, now this is just how this one's working out. F of x, let's go ahead and find f of x. X is 5. 5 squared is 25, okay? And I think we have h already. So now the difference quotient is going to be equal to 64 minus 25 divided by 3. All right, that's what, 34, 39. So 39 divided by 3, which is 13. Okay, so that's an introduction to difference quotient. Now, difference quotient, it can be a little bit intimidating for students, but it gets better. This is an introduction to what we mean. We're building a foundation for what we mean by differentiation, but this is kind of like extra. I don't want you to get too bogged down into this stuff. I really, the intent of this, or the intent of my presentation, is for just to just kind of touch on these ideas and concepts. I don't want you to get too bogged down into it. Once we get past this, like, there are shortcuts. Like right now, we're going to be working on questions that's going to fill up the whole page. But then in like a few sections, we're going to see shortcuts where all that work that we were doing, we can just look at it and just spit out the answer, right? So there are some shortcuts that are coming that, to me, I enjoy them and they're fun and much more simple. But we need to just lay this foundation first. So then for part B, let's do the same thing, right? So if we want to find f of x plus h, so for part B, our x is 5, and now our h is 0.1. So then we want to find f of 5.1. Hey Siri, what's 5.1 times 5.1?
5.1 times 5.1 is 26.01.
26.0. Okay. So this is going to be 26.01. Did you know that Siri can do math? All right. All these virtual assistants can do that kind of stuff. All right. So this is f of x plus h, right? Then we need to go ahead and find f of x. The x in this case, I think, was 5. So I think we already took that was 25. I'm going to kind of continue working over here. So then for part B, our difference quotient is going to be, headphones are losing life. All right. Hopefully you guys. Let me make sure my. We're still live. Can you guys still hear me okay?
Yes, sir.
Yeah, we can.
Yeah, we can hear you.
Okay. So let's see. F of the x plus h we got was what? 26.01 minus 25 over h in this case was 0.1. What is that? 1.01 divided by 0.1. I'm gonna you can use your calculator. I'm gonna multiply by 1 in the form of 10 over 10. Okay. So this gives me 10.1. I think that's it, all right? So that one ends up being 10.1. So these examples were evaluating a difference quotient, given some conditions. All right, we got 13 and we got 10.1. Let's see how do we do. All right, I think they verbatim did the same thing that we did. We got our 13, and then I think for part B, they got the 10.1. Okay. So again, those examples were just evaluating a difference quotient. Let's take it a step further, right? So for f of x equal to this, find a simplified form of the difference quotient. Okay, so again, we're doing difference quotient, so it's a good idea to write it down. My recommendation, every time you use a formula, write it down. Also, every time you come across a formula, hopefully you're taking notes and you have I would recommend have some places easy to find in your notebook where you have a collection of formulas. I would add the difference formula to that collection of formulas, right? So the difference quotient again is going to be f of x plus h minus f of x over h, right? That's the difference quotient. Again, I'm going to go ahead and label this as star for reference purposes. So this is our f of x. Find a simplified form of the difference quotient. Okay, so the first thing we need to find is f of x plus h, right? So then that's going to be, basically we take f of x, which is x cubed, and we replace the x's with x plus h. If we expand this out, it's going to be what? X squared. I think I know the result, so I'm just going to just write the final result. Let's see, I think it's like x cubed plus 3x squared h plus 3xh squared plus h cubed, right? If you like, basically it's binomial times binomial times binomial. So you FOIL the first two and you get like a trinomial, and then you say that trinomial times the binomial, you should get this result. I think this is correct. I'm just gonna go with this for now, okay? That's for f of x plus h. So I think we are ready to find the simplified form of the difference quotient. So then I'm gonna say the difference quotient is gonna be equal to x cubed plus 3x squared h plus 3xh squared plus h cubed, then what, minus f of x, which is going to be minus x cubed all over h, right? So then if we've done this properly, this is going to cancel this, right? Notice that each term still has at least one h remaining, right? So what we want to do next is factor out one h from each of those remaining terms, right? So if we do that, we get the following. We factor out the h, so we're going to be left with 3x squared plus 3xh plus h squared, right? So if we take one h from each of those terms, this is what's left over, right? So now we're ready for these h's to cancel. So when we do difference quotient, the main two components that you're looking for, the f of x should cancel some terms from the expansion. And then if done properly, the remaining terms should all have an h that you can factor out, and those h should cancel in this fashion, right? So it's usually two main things that we're looking for when we're simplifying difference quotients. Okay, again, I don't want you to get too bogged down in this. Just do the best you can. I want to say it gets, I very gingerly want to say that it gets easier, right? But obviously there's some other concepts in here that get a little bit wild. So, you know. But yeah, when we do that simplification, then we get 3x squared plus 3xh plus h squared, right? So this is where we're stopping right now. This is our simplified difference quotient. Okay, we haven't combined this with the notion of limits just yet. Okay, so we got 3x squared plus 3xh, and again, trying to follow somebody else's math, I can't even do it. I'm a professional, and it takes a lot of my energy and focus to follow somebody else doing math. The only way that I really get it, when I'm watching somebody else do math, I get ideas and tricks and tips, but then I don't really get it until I go do it myself. So something like this, trying to follow what I'm doing, it might bore a hole in your head, right? Just pick up whatever you can. Don't try to follow every little nuance. Just pick up what you can. You don't really get it until you take it and sit down and do it yourself. That's the only time that you really see it when it comes to mathematics. This whole experience is a very intimate thing, and you really only get it when you do it yourself. But you know, it just takes a little bit of effort to get to that point. Okay, so let's keep going. So here's a type version of what we just did, and I think they got the same result. Again, now my goal was to have already been, and we're almost to section 1.4, so again, we'll do the best we can. I'm going to leave this quick check as an exercise for you. I think I did go through this on my pre-recorded lecture, so I'm going to piggyback off of that, and let's talk about this one. So for f of x equal to this, again, find a simplified form of the difference quotient. I actually think I'm going to defer to my recording for this, just for the sake of time. Here's a type version of everything and a summary, right? So I'm gonna piggyback. So the things that I didn't talk about in this moment, I am gonna piggyback off of my pre-recorded lecture, because you know that's my business. You know that's another Tabitha Brown thing. But I do go into details on my recordings. I'll leave that there. And then what I'm going to pull up, I want to go to edit. Can I suppress that? I just want to see which is which. That's the handwritten, so I want to duplicate this one. Duplicate. And I want to say all these notes and everything are already on our Blackboard page. So now what I did, I went on and pulled a blank copy of section 1.4. And section 1.4 is regarding a differentiation using limits of different quotients, right? So we just spoke on difference quotients, right? Again, difference quotient is nothing but the slope between 2 points. We've just changed the labels. We changed the labels from x1, y1, x2, y2 to x and x plus h, f of x and f of x plus h, right? That's all that we did. So, and then again, limits are concerned with how the function behaves as we get close to some number. So now we're going to mash those two concepts together, right? Between slope and difference quotient with limits, right? Seeing what happens as x gets close to some number. So what we're going to be doing, we're basically going to find the difference quotient similar to what we did. And then once we get to that simplified form, we're going to take the limit of our answers, right? That's all that we're doing. I'm doing the best I can to try to remove some of the anxiety from it. Now, again, as far as math and anything in life, if you want to minimize your anxiety, all you have to do is start earlier. Like when you procrastinate, which I'm the king of procrastination. That's the only reason I know this, because my favorite thing to do is procrastinate. But I am aware that when I procrastinate, all it does is create anxiety in me. To reduce my anxiety, I just start earlier. So if I don't want to if I want to minimize my anxiety, I just start moving early, right? So I say that to say, that's why I went on and made all of your homework and quizzes available. The only thing you don't have access to right now are the exams. So this is for this kind of thing. This is why I encourage you, the group me, definitely go ahead and seek out the tutors. And if you wanted to just take this information, take my recordings and sit down with the tutors, again, that's what they're paid for. Otherwise, they're just sitting there waiting for people to show up, right? That's what I was doing when I was a tutor. I was just sitting, waiting for people to show up. People showed up, I helped them. Otherwise, I just did whatever I needed to do with my time, right? But I was paid to be there. And I'm still kind of being paid to be there. And my goal is to be on the beach being paid to be there, because I can do it right now and I will do it. But anyway, okay. So I'm going to step away for just a moment. I want to get some water. And we're going to go ahead and move into section 1.4. And again, I don't feel so bad about skipping stuff, because I know I went through this stuff in my pre-recorded lecture where we have the time. At this time when we're meeting, we don't really have that lecture because we're kind of pressed for time. Man, water never tastes so good until you get thirsty. Then it's the greatest thing since sliced bread. Okay, let's shake it off and let's go on to the next one. Okay, so section 1.4, again, now we want to introduce this notion of what do we mean by differentiation using limits of difference quotients, right? So now we're going to introduce this concept of what do we mean by a derivative. So some objectives here. We want to find derivatives and value of derivatives, and we want to find equations of tangent lines, right? So we want to introduce with some definition or two. Let me check something else really quickly. It still says live. I think my screen is still sharing. Okay. So now, in the previous section, we kind of recapped this notion of what a secant line is. Remember, a secant line is a line that intersects a curve more than once, right? So now here what's going on, we still have our initial x value, right? And we're associating it with the point P. And then we have this second point. So now we consider some change in x, right? And it generates a second point. So in the last section, we talked about the slope of the secant line between our first point and second point. So now what happens as that change in x gets smaller and smaller and smaller, right? So as that change in x gets smaller, this second point gets closer and closer to our first point, right? So then what the whole point of this is all building up to this notion of, suppose we wanted to find the slope of this tangent line, right? So a secant line is a line that intersects a curve more than once, right? Boom and boom. A tangent line is a line that intersects a curve at one point in this fashion, right? It kind of grazes the curve. It doesn't cross the curve hard like this. This is not a tangent line. That's not a tangent line. A tangent line grazes the curve in this fashion, right? So now, without this technique, if we wanted to find the slope of that tangent line, if we just tried to measure or eyeball it, it would be difficult because this is also a tangent line that passes through that point. It gets kind of difficult when you're close, right? And all three of those drawings, even though they're tangent lines, when you're doing it manually, you have a margin of error, right? And so it's kind of difficult to find the slope, the true line, so you can find the slope of the tangent line. So what this limit does with this notion of considering a second point and seeing how the function behaves as the second point gets closer to the first, the closer the second point gets to the first, the better the approximation the slope of the secant line is to the tangent line, right? So let's try that one more time. As long as we're considering that second point, we have a secant line, but as that second point gets closer and closer to that first line, it gives us a better and better approximation for the actual tangent line, right? So as we choose points that are closer and closer to the first, the slope of the secant line gives us a better and better approximation for the slope of the tangent line. That essentially is what the derivative is. The derivative is like the slope of the tangent line at a point, right? And we use the limit definition to get the best approximation of the slope of the tangent line at a point. That's essentially what it is. Hopefully that made sense and that wasn't too wordy. That's the background or the meat and potatoes of it. Now, so again, whenever we talk about derivative, before we were doing difference quotient and we were talking about the slope of secant lines, the derivative is the slope of the tangent line at a point. It's nothing but the slope, but it's just the slope of a tangent line versus a secant line, right? So hopefully that was okay. I feel like that was better than my pre-recorded lecture. But the slope of the tangent line at a point is given by the limit as h tends to 0, as that small change in x tends to 0 of the difference quotient. Okay, let's try that one more time. The slope of the tangent line at a point is, the slope is the limit as that small change in x tends to 0 of the difference quotient. So as that change in x gets closer and closer to 0, we're going to take the slope, right? This limit is also the instantaneous rate of change of f of x and x, right? Okay. Hopefully I haven't scared you all away. Let's kind of go a little further. So for a function y equals f of x, its derivative of x is the function f prime defined by this, right? So what we mean by derivative, the derivative is the slope of the tangent line at a point. That's all it is. And we find it by, this is right now how we're introducing finding it. We're gonna have a better, more efficient, faster way to find these derivatives. This is just an introduction, and this is like backstory. So don't get too bogged down into it. I just wanted to lay a good, solid foundation. So the derivative right now is gonna be the limit as h tends to 0 of the difference quotient, okay? Provided the limit exists, if f prime exists, then we say that f is differentiable at x, right? So we have a curve, we're considering some point on the curve, and we consider the tangent line that passes through that point on the curve, right? So the derivative is just the slope of this tangent line. That's all derivative is, okay? All right. So now we have this example. Let me see the time. Now I don't want to keep you, we got about maybe right at about 20 minutes remaining, okay? So for this example, for f of x equals x squared, we're asked to find f prime and then find f prime of 3 and f prime of 4, right? So now, right now, again, we're gonna have a better presentation, but right now we're using the limit definition of the difference quotient to find the derivative, right? So right now, f prime of x is equal to the limit as h tends to 0 of the difference quotient, which is f of x plus h minus f of x all over h, right? We're taking this limit as h tends to 0. Okay, so let's find those corresponding components like we did before. So first, let's find f of x plus h, right? So then that's going to be, let me see, what's our f of x? So that's going to be x plus h quantity squared, which expands into x squared plus 2xh plus h squared, right? That's f of x plus h. We got f of x, okay. So now let's go ahead and find f prime. So then f prime, which is just the slope of the tangent line as h tends to 0. This is going to be the limit as h tends to 0 of, now f of x plus h, we said is x squared plus 2xh plus h squared minus f of x, which is x squared over h. Okay, let's keep going. So now we have some cancellations. Remember, when we're doing difference quotient, there's the first cancellation right there. Notice the remaining parts still have an h, which is what we want. Okay, so now let's factor out those h's, right? So I'm just want to factor out the h's. So then we factor out h, that gives us 2x is what's left there plus h over h, right? Oh, and we need to still include that limit portion. The limit, we still need to include the limit as h tends to 0. Right? So now we factored out our h's. This is canceled by that. Okay, and I think we're essentially ready to take the limit. This is going to be equal to the limit as h tends to 0 of 2x plus h. So at this point, when we kind of introduced limits before, at this point, there's a property that says we can just essentially just substitute in, right? So then this is going to be, if we just, now we can just substitute, this is going to be 2x plus 0, which is just 2x. So long story short, f prime of x was 2x, right? So now where here, it took us the whole page to get that, we actually have shortcuts where we can jump straight to this answer. All right, we just got to do our best to get past this. But we have shortcuts that take us straight here. Okay, so we have our f prime. Then we're asked to find f prime of 3. Sorry, f prime of -3. So then that's going to be 2 times -3, which is -6. Okay. And then we're asked to find f prime of 4. So I'm just going to put a comma and then do f prime of 4 is going to be 8. Well, let's just write 2 times 4 is 8. Okay. So we have a type version of what we just did, and let's compare and see how do we do. So you see the derivative here, f prime of x is 2x. All right, so that's what we got. And then f prime of -3 was -6, and there's the 8. Okay. So again, stop me if we can go back, or if anything is not clear. These are recorded. We got about 10 minutes remaining. And I know that there was a student that needed some assistance that I asked to remind me towards the end. So just hopefully you're still there. Okay, yeah, we got like just 10 more minutes. Give me like 10 more minutes and then we can do what we need to do. Let's see. So for this example, we're asked to find f prime. So now, for instance, if I was using a shortcut, which we're going to talk about, like these properties, this is a good amount. So that kind of steps away from being complex, and that one just moves into information overload. But the shortcut here, I don't want to say it. I'm just going to write the answer for now. All right. So if that's our f of x, then our f prime should be 3x squared, right? I'm just going to kind of do that. We'll talk about the shortcut that's coming up. I'm going to do one more demonstration on the difference quotient, the limit of the difference quotient technique. So f prime, the limit as h tends to 0, f of x plus h minus f of x all over h, right? Okay, I know we kind of got jammed there a little bit. Let's see, f of x plus h. Let's go ahead and find f of x plus h. Okay, that's going to be x plus h cubed. Okay, I think we found that already. So that should be x, whoops. I think it's getting temperamental. That's going to be x cubed plus 3x squared h plus 3xh squared plus h cubed. Okay. And we're going to reference the difference quotient. I'm just going to call it star. So then the difference quotient, or the derivative, actually, I'm not going to call it star. So then f prime is going to be the limit as h tends to 0 of, now we got this f of x plus h, which is all of this stuff, x cubed plus 3x squared h squared plus h cubed minus f of x, which is x cubed all over h, right? Again, when we're simplifying these difference quotient, there are two main components we're looking for. Here's the first one. Those cancel. The next thing is we know we did something right if the remaining terms all have h in them, right? That's usually a good sign. So I'm going to drop down. This is going to be equal to the limit as h tends to 0. Now, if we factor out h from all of those terms on top, we're left with 3x squared plus 3xh plus h squared, all divided by h. Okay, this h cancels that one. Okay, and then we have the limit as h tends to 0. We got 3x squared plus 3xh plus h squared. So then at this point, there's a property that says that we can just basically plug in the limit, right? If we're going as h tends to 0, if we just plug in the 0 for h, this term collapses to 0 and this term collapses to 0, right? So then this is just going to be 3x squared, which is what we said earlier, right? So all this work that you saw me do on the page, in a section or two, we're going to just discuss some shortcuts and just jump straight there, right? Okay, I'm watching the clock. So then they asked us to find f prime of -1. So that's going to be 3 times -1 squared, which is just 3. And then we're asked to find f prime of 1.5. That's going to be 3 times 1.5 squared. Now I know 15 times 15 is 225. So then this should be 3 times 2.25, 6.75. Okay. Again, you can use calculators. I just periodically like to practice my mental math. So we got 3x squared. We got 3 and 6.75. Let's see how do we do. So you see the 3x squared here. Here's a type version of, I think it's the same things that we got, okay? And then f prime of -1, you see the different results that we got there. Okay, we did pretty good. Let's keep going. We got a solid 6 more minutes, right? So let's take advantage of it and go as far as we can go. Again, I'm going to leave the quick check for you as an exercise. I think I went through these in the recording. Find f prime of x. Let me see what's after this one. 3. Quick check. Okay, yeah, let's use the remaining time for this. So then we have this notion where a function is not differentiable, right? So again, the derivative is the slope of the tangent line at a point. So then we can't talk about the slope of a tangent line at a point whenever we have a corner, right? So a function f of x is not differentiable at a point x equals a if there's a corner at that a, right? So this function is not differentiable there, it's not differentiable there, it's not differentiable in these locations. So if there's any sharp corners or edges, we can't take the derivatives at those values of x, right? Another place where a function is not differentiable, a function f is not differentiable at a point x equals a if there's a vertical tangent, right? Because if you try to take the derivative, the slope of a vertical line is undefined, right? So we can't take the derivative when we have a vertical tangent, all right? Because that slope is undefined. So we say it's not differentiable at that value, okay? And then a third place where a function is not differentiable is where the function is not continuous, right? So if we have any holes or gaps or breaks, when x is -2, right, there's a gap, so we can't talk about the slope of the tangent line at that point. So we have a gap here, so we can't take the derivative at that value, right? Quick check, I'm gonna leave that as an exercise, okay? Is that it? And that was a summary. Wow, we actually made it. So with proper, I think that's enough for one day though. I don't wanna, I know that was a little intense. That's just the nature of the beast. I did my best to try to make it as light as possible, but that's just the nature of it. Let me do the summary. I'll pause. I know there's one student we need to kind of work with. I'll probably stop the stream at that point. But let me do the summary really quickly. So again, a tangent line is a line that touches a smooth curve at a single point, right? We call that the point of tangency. Okay. And then the derivative of a function is defined by this. The limit is, and this should be h, right? I think that's a typo. That should be the limit as h tends to 0 of the difference quotient. Let me kind of note that here. I think that's supposed to be h. And then, so the slope of the tangent line of y equals f of x at x equals a is the derivative, right? That is, the slope of the tangent line is f prime of a. Slopes of tangent line are interpreted as instantaneous rates of change, right? So the average rate of change, we had it was basically the slope of the line between 2 points. So the derivative is the slope of the tangent line at a single point, and we consider that the instantaneous rate of change. So whenever you see instantaneous rate of change, we're talking about the slope of a tangent line versus the slope of a secant line, right? The equation of a tangent line, so basically once you have the slope of the line and the point on the line, this comes from the point slope formula, right? That comes from the point slope formula. It's basically going to give us the equation of that tangent line at that point. If a function is differentiable at a point x equals a, then it's continuous at x equals a. So in other words, it's saying differentiability implies continuity. However, continuity does not imply differentiability. So if a function is differentiable, that implies that it's continuous, but just because a function is continuous, does not necessarily imply that it's differentiable. Okay. For instance, if you consider f of x equals absolute value of x, that function is continuous, but it's not differentiable at the vertex of that function. And then these are the three conditions where a function is not differentiable. Say there's a discontinuity, which is like a hole or a gap or a break in the graph. If there's a sharp corner or an edge, then you can't talk about the derivative at that corner. Or if there's a vertical tangent, because tangent lines have an undefined slope, so we can't talk about the derivative of when we have vertical tangent lines. Okay. Okay, so we actually made it through sections 1, 3, and 1, 4. Now, I don't intend like for the entire semester to be 2 sections a day, but like for a week or two, we do need to do 2 sections a day. But then I'm doing my best to slow the speed down. The goal is for this semester is to get through chapter 4, which is integration, right? I feel like it's not a good calculus class if you don't make it through integration, because that's the foundation for so many things past calculus, just so many things. So we have to talk about integration, but integration occurs in chapter 4. So basically we're trying to get through 4 chapters before the end of the semester. So it's a little bit, so because there's so much information, the way I decided to offset it, I did kind of dial back on the homework a little bit. Where in the past I would have assigned maybe 20 questions. Some of those assignments I've only assigned maybe like 9 or 10 questions, right? So that was the offset that I decided to do to try to encourage you all to kind of keep moving through this material. And with that, we're going to actually end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, guys, take care.
Thank you, Professor.
Thank you, Professor.
My pleasure. With if you have questions, are you comfortable with me streaming them, or would you rather me stop the stream for your question? Like, are there anybody that has questions that they don't mind other students hearing before I stop the stream?
I have one question.
Go ahead.
For you said that you'd be recording, right? So I was trying to figure out how do we watch recording since they record on Zoom?
Okay, so I'm live streaming this to my YouTube, and so to access my YouTube, if we Blackboard, when you log into Blackboard, it basically looks like this, right? Once you click on Calclus for Business Spring 2022, that link number 4 takes you directly into this playlist where I'm compiling all of these recordings for this semester. So that takes you directly into my YouTube link.
Okay, I appreciate it.
My pleasure.
I got a question, Professor. So let's say you bought
All right.
let's say you already buy the place where you do our homework. What's it called again?
Pearson.
Pearson. Yeah, in the
Mhm.
past, we still have to pay for it, even though we paid for it in the past.
As
Like-
long
like
as
it's different.
as long as it's the exact same book, you don't have to pay for it. So when you access Pearson in the past, as long as it's the exact same book, you can use that same login information, and you'll have full
Well,
access.
well, let's just say it was a different like course per se, but it was
As,
still Pearson.
as long as it's the exact same book. If it's a different course, it's a good chance it's a different book. It's all based on the book.
Okay.
Yeah. Any other questions for the YouTube family before I stop the stream? Okay. Let's stop the stream.